We are solving two questions based on de Broglie's concept, dual nature of the radiation of the matter. The first problem is the momentum of the photon whose energy is 1 million electron volts is how much? You know, as per the de Broglie concept, lambda equal to h by p, that is the momentum. But this lambda is not given, rather energy is given for you. So energy can be written like h nu, that is hc by lambda. So in the place of lambda, I can write hc by E. Substitute this lambda here. That implies hc by E equal to h by p. H and h will cancel. P into C is E. Momentum equal to E by C. That's what our equation is. Where E is energy, which is given for you as 1 million means 10 power 6. Electron volts into joules, 1.6 into 10 power minus 19. That this energy becomes joules by 3 into 10 power 8. So 1.6 by 3, 10 power 6, 10 power minus 19 plus 8 becomes minus 8. That is 1.6 by 3 plus 6 and minus 8 means minus 2. Minus 2 and minus 19 is minus 21. So 1.6 into 10 power minus 21. 1.6 means 0.3 5s are 15. 10 is remaining. 3 3s are 9 into 10 power minus 21. That is approximately 5.3 into 10 power minus 22. But that 5.3 is not available in the options. So we have to choose the approximate answer. Momentum, so its units are kilogram meter per second. That's how we have to solve that problem. Let us see the other problem that is available now. The de Broglie wavelength of an electron moving with a certain kinetic energy is how much? Kinetic energy is given for you in the problem as 144 electron volts. To simplify that, we can use a definition of potential as work done per unit charge implies work done equal to VQ. So kinetic energy can be expressed as VQ, or Q is nothing but electron, VE. So VE equal to 144 electron volts. Electron can be cancelled. It means to say the applied voltage is 144 volts. Having energy 144 electron volts means we have applied a voltage of 144 volts. In that case, you can write a formula lambda equal to h by p, where p is momentum. But we know kinetic energy is p square by 2m. So momentum equal to square root of kinetic energy into momentum. So in the place of p, I can substitute that value lambda equal to h by square root of kinetic energy and momentum. But in the place of kinetic energy, as I told you, you can write a value something like VE. So h by square root of 2m VE. So these are all hectic values, like h equal to 6.6 into 10 power minus 34. Mass of electron is 1.6 into 10 power minus, 9.1 into 10 power minus 31. Charge of electron is 1.6 into 10 power minus 19. Substituting all the values, and if you simplify, you will get lambda in angstrom in this format. After substituting all these values, I just want you to substitute and confirm that you will get this equation. You will get it. I just want you to confirm it, right? Yeah. So lambda in angstrom is 12.27 by square root of voltage is 144 volts. So 12.27 square root of 144 is 12. So that is 1.02 angstrom. Though you got an answer, you don't have this option in angstroms. So lambda is 1.02. Angstrom means 10 power minus 10. 1.02 into 10 power minus 1 and then nanometer. So your answer is 0.102 nanometer. That's the answer. But that is also is not available, 0.102. So but you can see this 10 power minus 3 means it becomes 0.102. So that's the option, right? Or else you can express this as 102 into 10 power minus 3 nanometer. That's how we can solve this problem. Thank you for watching.